No, you don't have it.
Yes, I do.
Here we go. Sorry about that. First one was airlines. Shh, ladies and gentlemen. This was I cut pieces from another stuff. I got rid of the multiple choice questions on there. So first one, you were talking again about airline tickets, and as I've been stating all along, I really like how that initial worksheet that we were working on forced you guys to define variables. I think that by defining your variables first, it's going to help you to keep all of your data, all the stuff you're talking about straight. It helps to keep things clear. So remember, what I was doing, or what I suggested to you guys, is that as you go through these and you read it, I have business class and I have tourist class. Which one of those words did you read first? Business. So what I would do, neither of that was first, but whatever. So what I would do is I would call my X value business, and then my Y value will be tourist. Okay? Now, ladies and gentlemen, come on. As you go through the problem now, when you read it, your objective in this case is to maximize profits. How many tourist class seats should you sell? So you want to maximize profits. So that means you have to go back and reread the question and see where they talk about profits. Well, they talk about profits, $40 profit on business and $45 profit on tourists. So when I write up my objective function, which is the object of the problem, I have $40 in profit per business class seat plus $45 profit per tourist seat. That's your objective. Then you go back and reread again. It talks about specific parameters for each style of seat. One of the parameters states that the plane doesn't hold more than 30 people. Well, that's kind of an important thing. You can't hold more than 30 people. Can you hold 30 people? Yeah. Can you hold 31? No.
Pilots, because it's 30 passengers.
But I mean that the most sincere way. And it does talk about passengers as well, not about pilots, but that's another reading problem, so not mapping problem. Anyway, so we can't sell more than 30 seats on the plane, but we could sell 30. Does this problem, or did this problem talk about any specific parameters that one style had more than another or anything? Just some sort of combination of seats. All right. Now, it did have parameters on how many seats had to be sold per flight. It said that you had to have a plane, the charter of the plane, you had to have at least 5 business class seats, and you had to have at least 9 tourist class seats. The word "at least" means, can you sell more than that?
Yes.
Yes. Can you sell less than that?
No.
No. So 5 was the smallest amount, including 5, you could have for business, and 9 was the smallest amount you could have, including for tourists. Can we have negative tourists and business people? No. They could be in a bad mood, I agree. So this is implied then that we have what's called a first quadrant problem. As you go through this, we start to plot, what do you call them? Intercepts. Well, the intercepts we wind up with here are 30 and 30 for x and y. Everybody see that all right? So I plot them. Here's a 30, 0, and a 0, 30. When I shade this one, does it shade inward or does it shade outward? Inward, good. This one shades inward. So as you go inward with that, then it's a matter of looking at your other constraint points. Well, I have an x value that has to be greater than or equal to 5. So I have to kind of scale that to figure it out. Well, 30's here, 15's there, maybe 5's here then. That value of 5 remains constant because it's vertical. So as it hits this line here, the x-coordinate is 5. Remember what you're doing here. You're looking where these two guys now intersect. You're still doing a system of equations in this case. It just so happens that it's a very easy system of equations because you know what your x value is. If your x value is 5, what's your y value there? Good. All right. I do that again with my 9. 15's here, 10's about here, so maybe 9's about here. Again, I'm just scaling that to see how close I can go. So that 9 value goes across, which means when it hits here, not only is our x value constant at 5, our y value is also constant at 9. And then as it hits the diagonal, now we're looking at where those two intersect. Again, it's a system of equations, but yet you know your y-coordinate. The y-coordinate here is 9, which makes your x-coordinate 21. Now, I did not go back and shade through all the way yet, but greater than 5 was this way, greater than 9 is this way. So we're in that little triangular space right there. No, I'm in a triangle. Okay. Now from here we can figure out, I should ask you guys what the area of the shaded region, that'd be great questions for these things. So you have ordered pairs. And then we're just going ahead and substitute it into your constraint, or sorry, not constraint, your objective function. As you go back to your objective function, you got 5 times 40 plus 9 times 45. I did all these earlier. I got 5 and 9, that was 605. 21 and 9 gives me 1245. And the last one was at 1325. Which one of those gives you the largest profit? 5 and 25. Then it says, how many tourist class seats should you sell? 5. Okay. That's where you got to read your question carefully about what they're specifically asking. Okay. Yes, ma'am. We didn't have to do number 5. Number 5 has a weird throw in it. I'm not worrying about it. That would probably go. We'll do at least 3 of them. Number 3 is the same thing as number 1, really.
Yeah, I did that one wrong.
Back to a dance company. I know, woohoo. You have a dance company that's appearing at the University of Georgia. According to the school policy, no more than 2,000 general admission tickets can be sold, and 4,000 tickets for students can be sold. You have 50 cents per ticket to advertise for the students, and $1 per ticket to advertise for the general public. The dance company has an advertising budget of $3,000 for the show. Find the maximum profit the company can make if it charges $4 for a student ticket and $7 for general admission. Now, some people read into this a little bit too far than it needs to. If we're saying that you get $4 for it, think of this is your profit, $4. It's not, you have to worry about backing out the cost of advertising per person. That's going to be a completely different problem. If it's something like that, it would be worded where I wouldn't tell you what your profit is at all. I'd say a shirt costs you $20 to buy, you're selling it for $26. Pants cost you $15 to buy, and you're selling for $21. So on and so on. So I'd find the maximum profit you can make off of shirts. So the values there would be a little bit different, where you'd have to figure out what the profit is per piece. Here, if it says that they're telling you if that's how much they're getting, that's what we're going to say that's the profit part. Right? Because you have a constraint built in for how much they're making $4 off a ticket, $7 off the other one. Okay. I'm trying to keep it easier on you for right now. So first things first, identify our X and Y. I think the general admission ticket came first. We'll call that X. And then students or Y. And the only reason why I'm doing it that way is because that's what came first as you read the question. Your objective, $4 for students, $7 for general admission. And this is where you have to be careful. General admission I'm calling X. So it's 7X plus 4Y. Okay. Sometimes it'll switch you when you're reading the sentences. They'll put them in a different order somewhere along the line. That's why it's super important to define. Figure out the word, start second, to define the actual values you're working with. And then that'll help you keep it straight throughout. In this problem, they talked about money, like you were saying. The money that they can spend to advertise was given to us at $3,000. Could they spend more than $3,000? Could they spend $3,000? Could they spend less than that? Yeah, sure. So we know that your upper limit is $3,000, less than or equal to, and it costs you $1 for general admission and 50 cents for students. So $1 plus 50 cents. Okay. Then it said that, what was it, no more than 2,000 general admission and 4,000 students. So that means we can have up to and including 2,000 general admission people and up to and including 4,000 students. We have negative people. Well, besides you. Oh. Quadrant 1. Here's the big trick on this one for your intercepts. Our 1x 0.5y equaling 3,000 gives you an x-intercept at 3,000, but half of what is 3,000 for your y value? 6,000. That's where you messed up. 0.5 times y is 3,000. Half of what is 3,000? 6,000. Cover and solve. You divide by 1, right? Divide by 0.5, you get 6,000. That's where most people will make their mistake in this problem, especially when you deal with money, when you have 50-cent stuff. You have to remember that this means it's half a dollar. So if you're dividing by half, you are multiplying by its reciprocal. It's one of those tricks there, okay? So when you think through it, remember what that means. It means half of what is 3,000, okay? So you have a 3,000 for your x and a 6,000 for your y.
Oh, I thought you were
No,
That's
that's not wrong, because it's 6,000. Is this shading inward or outward, ladies and gentlemen? This one going inward again. This one's moving inward. And now I have a vertical and a horizontal to deal with. My vertical is at 2,000. Well, I've already placed 3,000 out here. So if I cut this in thirds, maybe about here. Oops. That's close enough. So there's my 2,000. Remains constant because it's an x equals value. It's vertical. So when I run into this equation here, I know that the ordered pair will be 2,000. Oops, forgot the 0, comma something. So 2,000 plus half of what number is 3,000? 1,000, very good. Okay. 2,000 plus half of 2,000 is 3,000. That gives me my ordered pair there. I go to my other intercept. My other intercept, what? You just went cross it. What happened? You just went like, just want to make sure you're all right. All right. What's up?
Is the graph required
It works cleaner because if you for the first few that we've done, everything's kind of moving inward wise. But once you start moving stuff inward and outward, you need a graph and figure out which way things are going to go. Okay. Yes, sir. I substitute x into here. 2,000 plus half of what number is 3,000? Subtract 2,000 over, you get 1,000. Half of what is 1,000? Again, 6,000, 3,000's halfway, 4,000's about here. Okay. That one runs into your diagonal again at your y value. So your y value remains constant at 4,000. So we have to substitute back in. Half of, yes ma'am?
so your x value is the students, right?
No, minor general addition.
Okay.
So if you did it the other way, yours are just going to be flipped. Okay, and you should still get the same result.
Yeah.
Okay. So my y value here is 4,000. So what's half of 4,000? 2,000. 2,000 plus what is 3,000?
1,000.
And moving down, inward, and inward. That gives me our bounded region. In there. Okay. So we have ordered pairs. 0, 4,000, 1,000, 4,000. Let me get those guys. Okay. As you substitute those through your values, oh, I don't have this one here. Let's see, the first one would be 16,000, if I'm not mistaken. 7,000 plus 16,000 is 23,000. 14,000 and 8,000 is 22,000. And then last one will be 14,000. So I'm getting a maximum value of 23,000. But the question was, how many student tickets do you need to sell? Well, my student tickets are the Y values, so I have to sell 4,000 student tickets. And if you had flip-flop your X's and Y's, your X value would be 4,000. It would have worked just the same. Okay. That's what that looks like. What's that? Not sure. 2,000's in there, but it depends on how you, which which ones you were working with. That's why we want to graph. Don't you don't follow the table. Trust me. What's that? The table will help you. You have to trust me. You got to try your graph. And then 3 is basically the exact same thing as 1. What you're looking at there, you've got 12 tickets, and 16 tickets have to be sold, and then it's like an X plus Y is 50, and it works really fast. What I did want to do is walk through number 4, because the numbers are a little bit larger. Sometimes people freak out when they see bigger numbers. Well, I'm sorry. Hopefully we'll get over it soon. In this case here, Reynoldo Electronica. It's fun. They make radios and tape players. When was the last time any of you even used a tape deck?
When was the next? Oh, wait a minute. I was
All right. They have a manufacturing plant, has a capacity to make it at most 600 radios and 500 tape players. It costs the company 10 and 12 respectively to make a radio and a tape player. They can spend $8,400 to make the products and make a profit of $19 on the radio and $12 on the tape player. Maximize profits. How many of each should they make? This is the one where you're going to say they're going to make 753 tape decks and 8,404 radios. I just made those numbers up because I don't know what it is. But what do they say first in the sentence? Radio or tape deck?
Radio.
Radio. So I'm going to call my X values the radio. My Y values the tape players. Your goal here, ladies and gentlemen, is to, again, maximize your profit. So go back and reread the problem, and you'll find that you get profit on a radio at $19 and $12 for the tape player. So we have a 19X plus the 12Y is our objective. Okay, so far so good?
Yep.
All right. Constraints. The first thing that I always like to go to is if they talk about something with money. Well, in this case here, one of the money things they're saying that they can spend, how much money they can spend on their manufacturing costs. The most they can spend is
$8,400.
so they can spend up to and including, oops, sorry, up to and including the $8,400. And then how much does it cost to manufacture each piece? Well, yes, sir. I hear you. What? Oh, well, what is it? Very good. So you've got 10 for the radio and 12 for your tape deck. Okay? What's that? No. It's how much they cost, but when they don't tell you how much they're selling it for. If it costs them $12 to sell it, and they're making $12 on profit, how much are they selling it for? So if they cost them $12 to make, yeah, and that's what they're getting.
Wait. I guess they make money on the tape instead.
I think you misunderstood what he was saying. It costs $12 to make, but for every unit they sell, they make $12 on it.
Oh, profit?
Yeah.
Yeah.
So that means how much are they selling it for? $24. Okay. Yeah. So then the last little bit was they had certain specific capacities at manufacturing. Those capacities were set at 600 and 500. So the radios they can make at most 600, and tape players were at most 500, which then gives us a whole bunch of constraints and intercepts. Remember what I always say to do before you scale anything out? Look for your large stuff. In my head, I see 840, and I see, what would that be, 700 for the first one? And then 600, 500. So it's not terrible. When we go to plot, obviously we are first quadrant. I think we've all figured that out by now with these. My first intercept I'm going to put is the 840. It's our largest one. And then on the y value, that would have been at 700. Is it shade inward or is it shade outward? Moves inward.
Did you give us one like December 5 for a skill check?
No, because there's an extra value thrown in there that's a little bit weird. We haven't gotten to those that style yet.
Something that we haven't done.
No, we haven't done something. We'll have some of those styles tonight because we're still, as if you haven't noticed, the ones that we've been doing are one that's got a slope and two are horizontal vertical. I want to start getting into the multiple setup ones. So we'll have a few of those. Okay. Going back to your x-intercept, your x value being 600. If 840 is all the way out to the right, half would be 420, so 600 somewhere in between half and here. So about there, I guess. Okay. I'm just scaling through, which means the x value as it hits this is 600. 600 times 10 gives me 6,000. 8,400 subtract 6,000 gives me 2,400. 2,400 divided by 12 would be 200. Very good. So my 200 for y value is set low, which means the 500 has to be above it. Y value remains constant when you are a horizontal line. 12 times 5 is 60. Add a couple of zeros, you get 6,000. 2,400 again on the other side. Divide that by 10 and you get 240. Good. It's nice when the numbers are clean, isn't it?
Yeah.
Okay. I did not shade any of this stuff for the horizontal and verticals, but as you can tell, they're all moving to the left and down. So we have our bounded region then. Let's change creative pens.
Yes, but it's not another 7 for you. So yeah, it's like a cat.
What if my smiley face has a nose? What does it mean? Is it wrong?
No.
He just did.
I'm just judging because it's different.
Judge you.
Everyone judges.
I know, and they're usually right. Anyway, softball. It's out of the park. Anyway, so now we have our ordered pairs to test. We had what? 0, 500, 240, 500, 600, 200, and 600, 0. The first one would yield, would that be 6,000? Yeah, 6,000. I'm not going to multiply that in my head. 10,560. Next.
13,800. And 11,400. Plus a 0.
I was going to say, that must be missing 0 there. Thank you, sir. Appreciate it. And then that means that our maximum profit value occurs at the 13,800, which means in my ordered pair, since I put radios as X, tape players as Y, I need 600 radios and 200 tape decks. Now, if you flip-flop your X's and Y's, you should still get the same ordered pairs. It'll still be the same thing. Your image would just be kind of flipped a little bit, okay? It would just be inverted. As long as you whatever you say they are to begin with, it remains itself constant. Okay. For those of you guys that did do number 3, people were asking first, because I wasn't planning on doing it. I'll show you the solution here. I think it was 1280, I believe, for 3. Where did I get what from? 1286.
I got 1276.
All right, well, let's reread it.
Everyone got 1276.
I might have typed in something incorrect. I might have hit the wrong button.